Hey, good afternoon, everyone. Just want to say hello, welcome everyone to this Path Marathon open source session. We're excited you could join us today for Daniel Shrader's session and intro to Git. This Path Marathon features back-to-back live webinars delivered by expert speakers from the Path community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when the recordings are available. I'm Ryan Cerny. I'm a solutions architect with a company called Arrowhead Systems in Oshkosh, Wisconsin. I just have a few introductory slides I want to read before I hand over the reins to Dan. Dan, next slide. And then if you require technical assistance, please type your request into the question pane located on the right side of your screen and someone will assist you. The question pane is also where you may ask questions throughout the presentation. Feel free to enter your questions at any time. And once we get to the Q&A portion at the end of the session, I can read your questions aloud to Dan for you. You're able to zoom in on the presentation content by using the zoom button, which is located on the top of the presentation window. And then please note that there will be a short evaluation at the end of the session. It'll pop up right after the session ends in your web browser. We greatly appreciate if you could leave some feedback. It's important for future events, so please take a moment to complete it. And then next slide, Dan. Just another little explore everything PASS has to offer. Keep learning all year long. Visit pass.org. Check out all the free educational resources available to PASS members. Connect, share, and learn. Next slide. This PASS marathon session is presented by Daniel Shrader. Dan's been dabbling with code since the late 1990s, currently working with Microsoft BI products in AWS. When Dan is in coding, he enjoys camping, building robots, and hanging out with his family. And then the next slide, Dan, and without further ado, I'll let Dan take over and go through the intro to Git.
All right, thanks, Ryan. Hi, everyone. As Ryan said, my name's Daniel Shrader, and I am a senior programmer at NextAir Energy in sunny South Florida, or rainy as it is right now. This is where I work with data scientists building pipelines to feed their predictive models with data from our over 10,000 wind turbines. And those turbines generate about tens of billions of data points a day, so we've got quite a bit of data to go through. I've been using a variety of technologies to move all that data, everything from Python, Docker, and Lambda to SQL Server Analysis Services, Redshift, and Power BI. Today, we're going to talk about how to get started using Git as part of your software development workflow. We'll cover all the major parts and see how it can be used to lay the groundwork for you to have automated deployments. All this without using the command line. And I'd like to start this with myths about Git. Every time I talk to someone who hasn't used Git before, these are some of the big questions and answers I kind of stumble into. The first one is it's too hard to use, and that one's kind of like anything that is new software. And it's just like a bike. When you started riding a bike, it was very, very difficult to do it. But after a while, it just came naturally. Git's going to do the same thing. Once you get proficient with it, you're not even going to notice that you're using it. I typically use it throughout the day, and 30 seconds here and there, and that's about it. The next one is that it's command line only based, and that was true at one point, but these days there's tons of different user interfaces, and we'll explore one that allow you to abstract the command line away and use a nice interface to go ahead and go through with your version control. The next one is that it takes too long, and I understand going from just writing code to having to stop for a moment and take a snapshot of your project or check in a file. It does take a little bit, but all the features that Git allows you to do after the fact more than amply makes up for the time. I'll give you an example. The first time that you have to roll a change back, you're almost going to catch up on all that time that you've spent writing or committing code. And then my final one that I used to hear an awful lot is that my project is too big and complicated for that. Everything from analysis services, tabular models, to Lambda functions. But that's really nothing in comparison to what Git was originally designed for, and that was to manage the source control of the Linux kernel. And that on its own is pretty big. But since then, a bigger project has come along and started using Git, and that's Microsoft Windows. So they actually check all their code into Git and use it for source control. So if you have something that's as big as that, that's might be the limit of it, but right now I believe that's the largest Git repo on the planet. And now I kind of want to talk about a few reasons to use Git, because let's be realistic, why do you want to use this software? What features does it give me that make it better for me to use it than not? And the first one's going to be multiple backups. Like I said, it takes me about 30 seconds to take a snapshot of a piece of code or of my entire project and make a point in time that I can go forward or I can go backwards. Really cool. And if you're on a team of people working, you can actually all work on the same file at the same time and get your changes tied together using Git. Like I said, I've used it on tabular projects, and if anybody's familiar with that, a tabular file is thousands of lines long. And most likely, you're all not working on the same exact spot. And what Git will let you do is it will allow one person to work on table A and another person to work on table B, or DAX calculation, whichever. And this is going to let you all work together and quickly iterate through and get your changes out there for your customers. The next bit that I really like is that I can roll forward and backwards in time. I know personally for me, being able to see when I potentially brought in a bug to the code is really nice, and to see when and why it happened. Other systems, you can't do that as easily. And finally, it's a skill in high demand. A few years back, Mid-America University did a survey of not resumes, but of positions, and compiled a list of what the top things were. Git took over half of them, and that's what the screen on the bottom right is actually showing. So, and it's a transferable skill, which is the biggest thing for me. If I go from this tech stack to the next tech stack. So let's just talk a little bit about how I got to this point, because I think it helps. I was looking for version control many years ago, and I wasn't sure what to go with. I Googled, and I found tons of different information. Git, some ones that were rolled by their own, SVN. I had at one point just copied files around and said, okay, this is version 1 folder, this is version 2 folder, this is version 3 folder. And it really, that didn't work. So then I got slick and I was like, oh, I'll use Dropbox or SharePoint. I can check files in and out, and that really doesn't work either, because it didn't give me what I wanted out of version control. I did get to say, yes, this is a snapshot in time, but I didn't get any of the other things that a proper version control would let me do. And finally, one of the reasons that I started using Git is because of all the content that's out there that helps you learn it. Pluralsight, GitHub, Atlassian, they all have wonderful tutorials. There's books out there. ProGit is actually free, and while it is very lengthy, it's extremely in-depth, and it will tell you anything you've ever wanted to know about Git. And when I was going through my learning, I kept finding all of these words where people were like, oh, just go do this, go do that. And so I put a list of them together, and these are the words that I found. And I looked at them and I was like, I don't know what any of these mean. They're doing this weird command or that weird command. Well, luckily today, not only are we only going to use a user interface, but we're only going to focus on these 15 words. And by the end of it, there'll be commands for you, because you'll know what to do. And they're going to let you get through 95% of anything you'll ever want to do with Git for the most part. And the software we're going to use is actually going to be SourceTree. It's an Atlassian product. It's free, so there's no reason that we can't use it. And it's a very good one. So to begin with, we're going to talk about the basics. And with Git, there's a a lot of things in it, but there's a few pieces that you're going to use over and over and over again. And we're going to talk about that here. The first step is, of course, you have to say, I want to start using Git on this particular folder. And that can be done in a few different ways. You can, in source tree, you can actually select the new button or init, and that's going to let you go ahead and just simply point to a folder on your computer and say, I'm using Git here. And that tells Git to actually start monitoring it for things. The other option you have is to clone an existing project. And we'll get into that a little bit later. But what that's going to let you do is it's going to let you take something that's existing and bring it right in. And as I said earlier, I'm down here in South Florida, and I'm lucky enough where I can actually watch some of the rocket launches happen. And I'm watching the rocket launch one day, and I realized that Git is pretty much the same process as a rocket. You have to build the rocket, you have to fuel it, you have to get ready to launch it. You send it up somewhere, and then it comes back down. And this is actually a workflow that works really good for the basics of it. So let's explore each one. The first bit is the add command. And it is going to, once you've told Git to start monitoring a folder, it's going to start bringing in everything that it sees within that folder. Now, some people might say, well, I just want to add everything. And that's not necessarily what you want to do with Git. You don't want to bring in any of the compiled files. You don't want to bring any of the backup files. If anybody's lucky enough to have worked with Tabular, you'll know if you're not running it with a server to back it up, that it creates tons and tons of data files in the background. You don't want all of those. It's going to cause you a few different issues. One, your repository is going to swell in size because they're always going to change. And two, when you go ahead and try to merge your code, and we'll talk about that a little bit later, you're going to be trying to merge files that add no value to you. So when you add a file into Git for it to start tracking these files, make sure that it's really a file that you want. It's one that you touched. It's one that the code inside of it makes sense. It's not these automatically generated files. The next step is stage. And stage is where you can take a file that you've told Git to, hey, I'm following this file. It lets you start to put it into a spot where you're going to be able to say, yes, these are the changes I want to save. And the cool thing with Git is that you can actually split the stage for one file into multiple pieces. And there's reasons for that. One of them would be to have more concise commit messages, which we'll talk about. And then the other is you might have pieces in there where you've turned a flag on or off to say, hey, I want to have debug mode on. Well, that's not necessarily something you want to commit into the code. It's just something that you're doing for now. So it'll actually allow you to break those files up into pieces that are more manageable or that are more relevant to what you're doing. And then finally, you have the commit. And this is where it's going to take that snapshot. It's going to say, okay, this is what I'm ready to commit to source control and have as record. And there's a few things here that you need to keep in mind. First is the commit message. This, while some people may go, it's not that important, this is actually extremely important for you later on. In about 6 months from now, you'll thank yourself for writing a good commit message, because what it's going to let you do is it's going to let you search these commit messages and say, oh, why was I doing this or that? And the other thing is you're going to actually be able to hand it off to someone and they'll be able to tell the same thing. Let me show you an example that I found off XKCD, which really helps iterate the reasoning. The first commit that they have on here is created a main loop and timing control. That really makes sense. I understand this is what they're doing. The second one, enable config file parsing. That makes sense too. Let's call, what is that? Now I can go right there and I know this is where that was brought in. Miscellaneous bug fixes, that's okay. I understand there's some bugs and they got fixed. But as you go farther down, you're going to see worse and worse commit messages. I wish this comic was funny because it wasn't true, but I've seen a lot of commit messages, and sometimes you start seeing update or A. That was my favorite, A. So do yourself a favor and do your coworkers a favor and write a half decent commit message. It's really going to make it easier for you later on. The next piece is push. And this command is pretty straightforward. what it's going to do is it's going to take these commit messages that you've done and send them to somewhere. In our case, we're going to be talking about, at least for this session, is a centralized workflow, and this will go to a server somewhere, whether you host it yourself or it's online. And speaking about that, that's what is considered a remote. Now, the simple definition for something more, but the choices you have out there offer a lot. I'll give you an example. A few of them out there, Bitbucket, GitHub, GitLab, they all offer different flavors of features. GitHub allows you to use Docker right through the pipelines product and deploy your code. GitHub, which Microsoft purchased recently, allows you to host static web pages right from there. They both have phenomenal issue trackers built right into them. So before you settle on a remote, just don't go with what you think sounds great. Take a quick look and see what features they offer. Maybe even try it out on a small project and say, oh, I like this or I don't like that. This is really, really nice to be able to do some of these things.
Hey Dan,
and the final one is pull. And what this is going to, yeah. Hey Ryan.
Hey, sorry to interrupt you. Hey, we're getting a couple messages that your audio is cutting in and out. I'm not sure if there's anything you can do on your end, but it's getting a little bit choppy.
All right, I'll let me see if I can get a little closer.
Sure.
Is that any better?
Yeah, go ahead and give it a shot.
All right. So the next piece is pull. And pull is going to allow you to pull the code from whatever repository that you have and bring it down onto your local machine. And this is going to be critical for you so that you can actually go through and actually get it onto another machine or share it with your coworkers. So with all that brought together, you're going to be able to see this pattern where you add the code, stage the code, commit it, push it to the remote, and then pull it back down. And if you get nothing else but that, you're going to get the majority of what you need to do with Git. Now, while all of that's great, the bigger pieces that are valuable for Git is branches. And branches are pretty simple in theory, and you can kind of picture them as being able to put your code in those old folders that I talked about earlier. And to get started with it, what you're going to do is you're going to go ahead and use the branch command. And what that'll do is that'll take the current branch that you're on, and so far we've only ever been on master branch, and it's going to copy it. And you can name this whatever you'd like. You can name it develop, whatever ticket number you are using, or the like. And that's going to go ahead and give you a new place to work. But you can't work on it right away. What you have to do is you have to actually use the checkout command. Once you check it out, you'll actually get to be on that branch of code. Now from here, you're going to go ahead and do what we had talked about earlier, where you commit, you push, and all the other great stuff. And then you're going to be able to, just work as normal. The great bit here is, let's say tomorrow you get a new priority and you can't finish up this code that you're working on this branch. You can actually jump back to master and check out and create a new branch and check that out and start working there. Because let's be realistic, priorities change sometimes. And when they do, it's nice that you don't have to go ahead and reset a ton of different things. Now, that's great that we've been working so far on this develop branch. We can commit 100 times, 2 times, 1 time. But what do we do to bring it in to the next one? And that's where we're going to do the merge command. And what the merge command is going to let us do is it's literally going to say, take this code that we have and bringing it back into the master branch. And it could be any other branch that we merge into. And 90% of the time here, it's going to go flawlessly for you. If you're working on a repository by yourself, you don't even have to think about it. It'll just work. Now, if you're working with other people, what you're going to want to do before you merge that branch is you're going to want to pull whatever branch that you're going to be merging into, pull it to make sure that you have all the latest changes. Because what that's going to do is it's going to let you combine them. And like I said, 90% of the time, no problems will ever happen. But sometimes you will run into a problem where Git can't figure out what's going on. An example would be is if I changed a variable name to A and you changed it to B. Well, Git rightfully so doesn't know which one to choose. So you'll have to go ahead and make that choice. And the way you do that is actually with a thing called merge tools. Now these aren't built into source tree, and you have a lot of options out there. A few of them are meld, which I've used in the past and it works phenomenal. KDiff3, which I know some people use, and Git Kraken, which is another Git user interface, but it has it built in. They all work. They have their pros and cons to each, but that's how you'll go through. But what really is going on with these merges? So let's kind of talk about that a little bit more. Let's just say we have a base branch. We have developer A and we have developer B. Developer A goes ahead and commits their code on their own branch. No big deal. Developer B does the same. They've committed their code. Great. Developer A then goes ahead and merges their code into the base branch and brings the base branch forward. Still no problems at all. Now, developer B wants to do the same. They're done with their feature. It may have taken a little longer to finish, may have been more complicated or something. They go to merge, and all of a sudden, they can't because the base branch has changed. Again, this is that variable A and variable B problem we just talked about. So what can they do? What developer B has to do is they have to go ahead and pull the base branch into their current branch and then go through and do a merge commit there. And that's going to let them true everything up. They can go ahead and run their automated tests if they have them, test everything else out, make sure everything looks good. And once that's done, they'll be able to go ahead and merge the base branch in. And that's going to cover most of the issues that you'll have as far as merging goes. But speaking about merging, there's something else that happens with a merge. And that's, excuse me one second. And that's called a pull request. Now, a pull request lets you do a couple different things. First off, it's a user interface if you're using a service that lets you actually collaborate and have code discussions. A pull request lets you take a block of code that you're doing, that you've committed, and say, I want to bring it into this other branch. And not only do you, just like a merge, but instead of merging it right away, what it lets you do is it actually lets you collaborate with others. So let's say you have a team that you're working with, you can say, hey, I'm doing this, change. What do you think? What that's going to let them do is it's going to let them see exactly the files that are changing, maybe even run those files, and then go through and say, oh yeah, this is great, or hey, maybe you need to work on this a little bit more. And when you're using a pull request to pull it into another branch, you're going to want to go ahead and keep that pretty concise. Only put pieces in there for parts that pertain to that request. And I know it sounds funny, but keep it respectful. A pull request isn't somewhere where you go, why would you ever do this? Why would you ever do a for loop or any other things? Or why would you not pay attention to our coding standards? It's a chance for everybody to grow a little bit and be able to say, hey, I saw that you named it variable A. Could you just go ahead and reference the coding standards and then, update the pull request like that? And finally, just like a commit message, don't be shy to add some detail here. You want to make sure that if someone is receiving this pull request, that they get as much information as they possibly can on it. This way they can quickly say, oh, yes, this is good, this is bad. So let's look at a couple examples. Here's an example where I am taking something from my feature test branch and doing a pull request to bring it into develop. In here, I've put the title of updated, update, and then description of updated stuff. Well, just like those commit messages before, that means absolutely nothing to me. Furthermore, when I send it out to someone saying, oh, hey, can you please approve my pull request? Now I've actually asked them, instead of just looking at my code and saying, oh, does this fix whatever problem I'm trying to solve? I've asked them to try to figure out the problem that I'm trying to solve. And that really isn't fair to them, and it causes it to take a lot longer to do this pull request. And quite frankly, if it's an open source project, it might get denied entirely. Now, here's a better example. And again, these are descriptions here. But what I've done is I've put a nice descriptive title here. I've put a quick sentence there, and then I've put a spot where I can put bullet points. Now, if you're working on something that has a ticketing system, it's really good for you to go ahead there and start saying, all right, this pull request is fixing problems A, B, and C. And then put that there. And that's going to let you quickly convey the idea of what you're trying to do. Now, we have a couple different workflows in Git, and you've heard me talk about naming branches. And we'll go ahead and cover two of the most popular ones. The first one is the Git flow workflow. And Git flow is actually really cool, especially if you're using source tree and learning Git, quite frankly. It allows you to have a button that lets you manage your merging and your branching. So let's talk about how this works. First, when you initialize Git flow, you'll start with a master branch. You say, hey, I want to use Git flow here. What that's going to do is it's going to copy that master branch right down to a develop branch. And they're going to be perfect copies of each other. Now, from this point forward, you're never going to go ahead and commit directly to either of those branches. It's just not something you'll do if you're using Git flow workflow. What you'll do is, let's say you have a ticket that's been opened up. You can go ahead and say, hey, I'm going to start on a new feature. Feature 1, 2, 3, or short description, your choice, depending on what remote you're using. Giving a ticket number actually sometimes joins them together, so it might be something you'll want to investigate here. And what you'll be able to do is you'll be able to put multiple commits onto that feature branch. So you'll go through the regular workflow cycle, stage your files, add if you need to, commit, push, and you can do that multiple times. But eventually you're going to want to get that code out of the feature branch and in. And by the way, before I forget, you can have multiple features going at the same time. So if you have multiple developers on your team, you can have multiple developers working on different features and not step on each other's toes. But once that feature is done, what you can do is you can go ahead and select the button Finish Feature. What that's going to do is it's going to go ahead and do that commit message and do that merge for you into the develop branch. And something, again, remember you'll want to make sure you've pulled that develop branch to make sure it's up to date and not have any issues later on down the road. And that'll let you take care of all of your, if you do have to do a merge or any of the other things where you're having a conflict, it'll let you do it on your feature branch. Then once it's been merged into develop, you can go ahead and select the release button. What that release button is going to do is it's going to create another branch for you. It's going to give it a name. It might be release 1. And you're going to be able to go ahead and start testing it, make sure is everything going to work good here. Sometimes and I'll attest to this on my own, you ran into a problem. Something didn't get turned off. You've got debug mode turned on, a dozen of other things. And what release is going to let you do is it's going to let you continue to commit on there. You're not going to want to commit too crazily on there. Make sure you get to the point where you can release the code. But when you're done, you're going to go ahead and say finish release. And that's going to do something a little different than what we've talked about today thus far. It's going to do a double merge, or really one merge and then a second merge. And this is so that since you've done some fixing on that release branch, you don't have to fix it again. It's going to merge into the master branch, and it's going to merge into the release branch. Now, if you follow this pattern and everything's been kept up to date, you're never going to run into a merge issue when you get a merge to master. And that's going to let you actually start picking up things and saying, hey, as soon as it goes to master, deploy the code. But there's this last piece I haven't talked about, and that's a hot fix. Now, I like feature branches and I like being able to do the releases in a nice orderly manner. But sometimes when production's down, you just have to get it back up and running at all costs. Production's down, we need it back. And if you were to go ahead and do a feature branch, you may have other features that have already been merged into the develop branch that aren't ready to go to production yet for whatever reason. They might be waiting on other pieces. There might be some other reason. So what the hotfix is going to let you do is let you click a button again and say, hey, I need to do a hotfix. From there, you can do one or multiple commits, most likely only one because again, you're trying to get back into production. And you're going to be able to go ahead and say, hey, here's my fix. Let me go ahead and finish this. And that's going to go ahead and do that same double merge. Now into master, it'll always be flawless again because you pulled off the latest commit for master and you merged right in. Develop, it's going to also do that same merge. This way you don't have to do that fix ever again, or even worse, reintroduce the same bug 1 or 2 times before it really gets squashed. But sometimes you'll actually have a merge conflict there. It's not the worst thing in the world, but sometimes you will. But the great thing is you can go ahead and spend your time to go ahead and resolve that on the develop branch. You don't have to worry about, oh, hey, I can't release it to the master branch. Now, I like this workflow when I'm in a team environment where we have that level of trust where we say, hey, these are the people that are working on this project. It lets us do a couple different things. First off, we can all work on the same file at different times. And secondly, when code is committed onto branches with these particular names, we can actually have build scripts that start picking them up and doing deployments for you. It's not something you have to you don't have to use this workflow and only have that. You can use and say, hey, if it's on master, we're going to manually deploy to here. If it's on develop, we're going to manually deploy to here. But it opens the door up for you to be able to do these type of things and not have to worry about, oh, how do we do this later on down the road? The next workflow we're going to talk about is the forking workflow. And this one is used more for public projects or open source projects. And the main draw to this is that those trusted entities that we talked about for the team don't have to be there because the only way things come in there is through pull requests. So let's walk through this example that we have here on the screen. In the middle, we have the main project. And for the first run, we're going to look at the contributing fork, which is on the left. Let's say I have a feature that I've decided I'm going to pick up a feature. I'm going to say, hey, I'm going to work on ticket 1, 2, 3. I can go ahead, I can fork that repo, which is actually making an entire clone of it and letting me work in a different spot. I can commit on it. I have full control over that project right there on my own private version of it. I can make everything go all the way through. And then I can say, hey, I'm done. It looks good. It looks like it's working. I can then go ahead and create a pull request from my private repository, or it can be open, but it's my repository that I have all permissions to, back into the main project, where the maintainers of that project can look at it and merge it in. This is really good because now those maintainers don't have to worry about, oh, hey, I want to start working on your project. Can I go ahead and get access to it? Or any other reasons, because that would be an administration nightmare for them. This lets me simply say, hey, I've done this fix. Here's my pull request, just like we were doing earlier. And then say, hey, can you go ahead and take a look at this? Can you test this out? And then continue from there. Once that's merged back into that main project, I can either keep working on my contributing fork, or I can fork that new one and then do additional ones. And that's how that particular side of the workflow works. The other side is more of an edge case, but is actually a really good purpose for it as well. And let's say you found a wonderful open source project that you like a lot, but you have this edge case that really doesn't fit into any of the boxes of applications that they want to bring into it. it's just really something that you need, or let's just say you want to hard code some values for whatever purpose, you can do something called a private fork. And essentially what that is you're forking that project just like you would on a contributing fork. You're committing on that project just like you would on a contributing fork, but you're never merging it back into the main project. And there are plenty of reasons to do that. But the great thing about doing this particular way is that you can pull that project back in later on if you get too far off and say, oh, they've added this feature that I need. And that's going to let you go ahead and get past some of those really weird things. And then we have a couple additional tools. I think some of these are really good to talk about. So let's look at them. The first one's blame. Now, the name of blame is a really, really bad name, and it's not to pick on your coworkers. Oh, look, so-and-so, they committed that bad line of code. Well, that's not what it's for. It's really to give you some insight without having to go forward and backwards a ton of different times through your different commits to say, when did this get introduced? One of the use cases that I can give you right off the bat is hunting down a bug. When did we add this? Oh, we added this 2 years ago. That's why. Another one could be if you're doing something with like a UI project and there's a green button and your customer says, oh, hey, that's always been a red button. Why is it green? There's a bug. Something went wrong. You'll actually be able to go into blame and say, and it's been in there for 4 or 5 releases and you signed off on it. I mean, we can change it back however you like, but it's been there for a while. It's not something that we're just arbitrarily adding for you to mess with your day. So blame is a very, very good tool. The next one is going to be tagging. And tagging, I don't think gets used enough, but what it allows you to do is it allows you to attach metadata to those commits that you've been doing. And one of the really valuable things is to be able to put your versioning on there. And if you don't use semantic versioning, I think I just lost the screen. Nope, there we go. It'll let you go ahead and easily say, is this compatible forward or backwards? Another thing that tagging lets you do is it'll actually allow you to put this special metadata on there. So if you wanted to pass commands along to automated build systems, for example, you could actually say, tag this as a build candidate, or tag this for special unit testing, so on and so forth. It gives you that ability to add that little bit extra metadata that doesn't belong in a commit, and it allows you to search on it. Again, these are some things that you want to be able to do later on. And then the next one is, nice. I seem to have a technical issue here. There we go, is reset. Now reset's going to let you do a couple different things. And before you decide you're going to use it, please make sure you commit any of your code and push it to your respective remotes. Because reset will do exactly what it sounds like it's going to do. And it's going to go ahead and reset everything that's in that file back to that point in time. And this is actually pretty cool to do. If you ever have the opportunity to play with it a little bit, or as you're learning it, you should, go ahead and add 5 files to a project. Commit them as you would go, push them, do whatever you need to do to make sure they're safe, and then reset backwards. And you'll actually be able to start seeing files drop or files add depending on what those commits that you had did. And by doing that, you're going to be able to give yourself the ability to actually run that code again. I'll give you an example, like when we're looking for those bugs. It worked yesterday. Well, what did I do? I did these 5 things. And when you're doing that, you can actually highlight multiple commits with source tree and see the changes in a particular file. That's going to let you go ahead and say, oh, hey, these 5 files changed. This is where my bug is. So it's a very powerful command. But like I said, make sure you have all your code pushed to the side, because when you go ahead and do it, it's going to cause you nothing but headaches if you don't check on that. And that wraps up a lot of it. I wanted to give some room for questions. I do have an appendix for any of the reference material that I had on there for those who are trying to find it later on. So Ryan, do you want to open it up?
Yeah, absolutely. So we do have a couple questions. And George, out in the audience, I'm not ignoring you, but we have three questions, two from Radu who are kind of related together. The first one, where will the interrupted branch in code be? Do I have to push or stash it before I switch to check it out from master?
Can you repeat it again?
Sure. Where will the interrupted branch of code be? Do I have to push or stash it before I switch to check out from master?
All right. Sorry. Um, when you go ahead and let's just say you're switching back, or say you want to pull that master branch, what you're going to do is you'll go ahead and commit your code like you normally would, and then you can push it to that remote. There's no, I shouldn't say there's no limit, but I've never run into a limit where I haven't been able to have multiple branches on that remote. So by doing that, what you're going to do is you're going to do two things. One, you're going to make sure your code's safe. Git's really powerful because it's distributed. Once you've cloned in a repository, you actually have it on that local machine. You can move forward and backwards. But at that same time, you have all that history. But if you don't push it up to that remote, you're not going to be able to go ahead and get to it anywhere else. So just to kind of summarize what you would do is, let's say you're going to try to get that master back up to date. You'll commit your code, you'll push it. You can then go ahead and check out your master and pull it to make sure there's no changes on it. And then you can go ahead and do that merge. Did that summarize it up?
Yep, that sounds good. The next one, also from Radu, kind of related more from the workflow side that you went through. Shouldn't the hotfix also be merged into any feature branch as well? And so that kind of tied into the get flow workflow piece.
All right, I'm going to shoot back there because I find it's a little easier to talk to it.
Sure.
Let me just, I think it's only a couple sheets back. So on the hotfix, let's talk about that for a minute. We go ahead and we have a problem in production. We say, hey, there's a problem, I need to get it back up and running. You're going to go ahead and hit that hotfix button, do the change, merge it back into master. Now that's also going to merge into that develop branch. Now you have a couple of options here. You can, if you wanted to, merge that also into feature, but you're going to get that when you merge that feature branch into develop. If you notice, if you follow the feature line, that it merges into that develop after that hotfix. That hotfix will actually make its way in when you go ahead and do that merge into develop. So again, you have a couple options. You can merge it earlier, which sometimes is always better. Or you can simply say, all right, when I go ahead and get ready to merge that feature into develop, I can pull develop all the way to the current one and then merge it in. Then you'll go ahead and you'll get that hotfix in there too. That's one of the reasons I really like that hotfix option with Git Flow. It eliminates the chance of, oh, I forgot to do that. The same with release. I forgot to turn that back off. Well, no, it made its way in there. So.
All right, we're good on that one. And then question from George, what is it about Git that makes Microsoft want to use it over teams like TFS or Azure DevOps, whatever the flavor of their product is now?
Right. Oh, that's kind of a loaded question. Git has a lot of features. I think there's a few things going out there, and this is purely my opinion at this rate. First off, if you're looking for people who know how to use a version control system, Git being open source and something that everybody can get to really increases the amount of candidates for you. First off, another one is that it's very, very lightweight. I have very limited exposure to Microsoft Teams, but with Git, I can do an awful lot without having to be tied into, oh, hey, I can't do it here. I've used Git on tons of different devices. I'm not stuck with oh, hey, I have to use a Windows machine or I have to use this machine. I've used Git on everything from a Chromebook and Raspberry Pi to a Windows server. It's everywhere that I could possibly imagine it needing to be. And there's tons of other pieces that I can do for adding into it. Um, Again, when you clone a repository, you're getting the entire history of it. One of the cool things, at least for me, is that I don't have to be constantly connected to the internet to use it. I can literally disconnect. I can,
We're losing your audio here.
there we go. How's that, Ryan? Is that better?
Yeah, that's way better. Yeah.
All right, excellent, excellent. Did I break up before I talked about it being offline?
Yes.
All right. So one of the great things about Git is that I can be offline entirely and not have to worry about, oh, hey, I don't have entire connectivity to XYZ system. There's some advanced features in Git that actually allow you to use repositories within repositories and reference them that way. So I can actually, and it's kind of out of the scope for this session, but I can actually use them as submodules, so I can break my code up into very granular pieces, or have it where I essentially have it like something like a Python plugin where I say, hey, I need to bring in XYZ repository and break it up that way. It lets me, do quite a few different interesting things, all without having to say, oh, hey, I'm exclusive on this one connection.
Very good. Next questions, two questions from Harish. When it comes to working with branches, is the only difference between merge versus a pull request the collaboration part of the pull?
Yes, that's really the big piece of it. At the end of the day, a pull request ends in the code merging, and a merge does that as well. That's going to be kind of, like I said, one is if you're doing that forking workflow, typically that's the only way you'll get that code into that repository is if it's gone through the collaboration. But if you're doing it where you can even use it with Git Flow, and that's a really great spot, especially when you want to do peer reviews. I find I might do a peer review and we might not even close the branch that particular way. We'll still manually merge it or whatnot. But that collaboration sometimes is really priceless just because you can say, hey, I'm trying to do this complicated idea and convey that. And depending on the platform that you're using for your remote, you might actually be able
Oh, we're losing your audio again, Dan. Nothing yet. Still no audio. Nothing yet. Nothing yet. Nothing yet. Still no audio. Still no audio yet.
There we go. How does that work?
Yep, that's better.
Okay. Yeah, I think this lightning storm's really messing with the wireless headset.
Yeah.
So where did I break up? Did I break up when we finished up the pull request?
Yes.
All right.
Yep. And
so
it's kind of the next question that was kind of tied directly into that, which is within the team project, should we be branching or should we use a fork?
Personally, I like to use branching if I'm doing something where I'm on a team and where we have that trusted relationship. They have access right into that project. The reason for it is it allows you to be a little quicker jumping back and forth between pieces, and it cuts down a little bit on the overhead, for lack of a better term. You don't have to worry about, oh, hey, I can't do this pull request here. With that type of thing, it makes it a lot easier. And again, since you're doing the branching workflow there, you can actually set up automation for CI/CD right off of that. I've had a lot of success with that, in a couple different projects where I'm able to say, if you're on my develop branch, send to my develop testing server. If I'm on my release branch, send to my QA server. If you're on my master branch, I can send straight to the production server.
There we go.
The overhead. All right, am I still there?
Yep, you're back.
Okay, great, cool. So do you have any more?
Yep, the last question here. Would you recommend Git to a company already using TFS with a small dev team and does not have a highly concurrent source code editing system?
All right, so if you don't have a lot of integrations with another system and you're just looking for the a type of version control to use, I would suggest Git, mainly because of all the third-party pieces that are out there for it. The Microsoft solution, while it's good from what I've heard, and like I said, I haven't been exposed overly to it. Git has a ton of different things out there that work directly with it. I've used Git with PowerShell, tying it into those type of things. And again, it depends on what type of setup you're going to use. If you're just going to use plain Git and not invest in having a good remote, whether it be Bitbucket on premise or GitHub on premise or something along those lines, or even the cloud solutions. I don't know if that was the right solution for you, but if you're willing to say, yes, we're going to do this, we're going to use, let's say, GitHub, and it's still Microsoft at that point, to go ahead and do all our, central code management, it's a really good tool. There's a lot of flexibility, a lot of documentation out there, and it lets you do a lot of cool things, even down to being able to analyze commit logs from, 5 or 10 commits or between 2 sets of commits to be able to react on those.
Okay. Sounds like I answered Radu's question. And that was the last question, unless anybody else wants to pop in quick. Any other questions? If not, I think that was it, Dan.
All right, excellent. And I gave everybody 5 minutes like we were talking about, so.
Yeah, perfect.
All right, well, thank you everybody for attending, and hopefully, let me see if I can get this screen